Hey everybody, welcome back. We are doing a unit on linear graphs and equations, and this is part 4. Today we are going to talk about vertical and horizontal lines and their equations, as well as writing a linear function given a graph. Hey, this is math class and we do problems and we review. Keep in mind, if you are following along at Socrative or Google Forms, and I refer to a number from the video, I mean the number in the upper left-hand corner. Let's use the slope formula by establishing a beginning and an end. Let's remove y2 and x2, which represent the endpoint. 6 is y2, and negative 7 is x2. Let's remove the beginning point in the formula. Negative 9 is y1, and negative 1 is x1. The top simplifies to 15. The bottom is negative 6. And that fraction reduces to negative 5 halves. Remember we talked about linear function machines? They do not have x in the denominator, or x is an exponent. X is not under a radical, and the exponent of x is 1. Number 2, which function equation is linear? In A, the exponent's too big. In B, x is the exponent. C, x is under a radical, and E, x is in the denominator. D is the answer. In the last video, we talked about slope-intercept form of a linear function, where m is the slope, and b is where the line hits the y-axis. In number 3, we should be able to identify a and c as nonlinear. Let's pick some lattice points. The vertical change in direction is negative 3, and the horizontal change in direction is 2. The correct ratio is the vertical change in direction over the horizontal change in direction. We can see that choice E has the correct slope. Because this is math class and we want everything to be right, let's identify that line L hits the y-axis at positive 2, and that's why this is plus 2. Number 3 is E. We are here today to write an equation of a line without it being multiple choice. When doing this, we want to start with y equals mx plus b. Let's rewrite it so we can take m out. Let's pick the lattice points. Remember, we only need 2. The vertical change in direction is 4, and the horizontal change in direction is negative 6. The correct ratio is the vertical change in direction 4 over the horizontal change in direction of negative 6. This simplifies to negative 2/3. Let's put negative 2/3 in the place of m. Now let's remove b, and in its place, let's put where the line hits the y-axis, which in this case is clearly negative 1. Plus a negative is not in simplest form. So let's rewrite this as y equals negative 2/3 x minus 1. If you are answering these questions at Socrative or Google Forms, neither have math type, so let's go to Socrative and see how to type in this result. Here we are at Socrative. You may want to pay attention to these directions. Remember, do not hit the space bar. In a problem like this, x is understood to be on top of the fraction, so when we type this result in, we type y equals negative 2x divide 3 minus 1. Once again, please do not hit the space bar. Well, that was a whole lot of fun. Let's do it again at number 5. Let's start with y equals mx plus b. Let's write it again so we can remove m. Find 2 lattice points to determine the vertical and horizontal changes in direction, which are 2 and negative 2. And 2 over negative 2 reduces to negative 1. So we put in negative 1 for m. Let's remove b and identify the y-intercept as negative 2. Now we input negative 2 for b. Finally, we want to write this in simplest form. When the coefficient is 1 or negative 1, it does not need to be written. And like the previous problem, plus negative 2 is best written as minus 2. At Socrative, type y equals negative x minus 2. As always, remember, do not hit the space bar. Number 6 is a continuation of the same fun game. Let's write down y equals mx plus b and remove m. I love lattice points and you should too. They help us find the vertical and horizontal changes in direction, which are 2 and 6. The correct ratio is 2/6, which reduces to 1/3. Let's put 1/3 in the place of m. Now let's remove b and identify the y-intercept as positive 2. So we put 2 in the place of b. Be careful when you move this x to the top to type it in at Socrative. I will code it for y equals 1x divide 3 plus 2, but the best form is to take the 1 out and type the result as y equals x divide 3 plus 2. I will code it both ways at Socrative to keep everybody happy. Hey, let's switch gears and talk about functions for a minute. Remember, in a function, there is exactly one output for each input. The idea of a function is there is an input and an output. Algebraically, functions look like this. In number 7, let's input -3 to obtain an output. -2 times -3 is +6, and 6 plus 3 is 9. Let's also talk about the vertical line test. If a vertical line can be drawn to hit a graph twice or more, then the graph is not a function. But why is that so? The coordinates of this point that hits the vertical line and the graph is -2, 4, and the coordinates of this point that hits the graph and the vertical line is -2, -2. So this is like a broken function machine where we input -2, and the output is 4, which represents this point, but we can input -2 again to output -2 this time, which represents that point. This function machine is broken because the definition of the function is there is only one output for each input. Therefore, this circle is not a function. Number 8 is true or false. The following graph is a function. That's one big false because if we put the vertical line test here, it hits the graph here and here. This is not a function. Number 9 is the same true-false question. If we use the vertical line test, regardless of where the vertical line is, it only hits the graph once. The answer is true. This is a function. Let's look at a function machine that only outputs 3. Is this function machine broken? Let's check it out. Let's input -1 and output 3. The graphical interpretation is right here. Let's input 2. This machine only outputs 3. On the graph, we map it here. Everybody's favorite number to input is 0, output 3. Now let's graph the point. Man, this is fun. Let's input 4. 4 outputs 3. That's this point way over here. Let's do one more just for fun. Input -5. Output 3. Graph the point. We can see that these points are making a line, and this line passes the vertical line test. So this function machine is not broken. Let's do the old y equals mx plus b thing on it. Let's remove m to find the slope. Let's use these lattice points. The vertical change in direction is 0. The horizontal change in direction is 7. 0 over 7 is 0. Let's put in 0 for m. Now let's remove b. This line clearly hits the y-axis at +3. So let's put in 3 for b. Anything times 0 is 0, and anything plus 0 is itself. So the equation of this line is y equals 3. So in a problem like number 10, when we are finding the equation of a horizontal line, we know it has 0 slope, not -3 or +1. We're studying linear functions that begin with y equals, not x equals. This line hits the y-axis at -2, so the answer is choice D. Let's finish our day talking about a broken function machine. This machine will only input -4. It might output +1. And let's interpret this with a graph. Let's input -4 again. This time, we're outputting -3, which would give us this point. Even though this function machine is broken, it's still fun. Let's output 0 this time. That's this point. Let's input -4 again. This time, let's output +4 and get a new point here. One more time, let's input -4 for fun and output -2 to get this point. Clearly, these points form a line, but any vertical line fails the vertical line test. This graph is not a function, and that is why this function machine is broken. Since it is not a function, we cannot use y equals mx plus b because it is an equation of a function. What we can do, though, is observe the equation of a horizontal line. It is y equals where it hits the y-axis, and make an assumption about a vertical line. It is x equals where it hits the x-axis. So the equation of this line is x equals -4. Number 11 and last problem of the day, which always makes me really sad because I'm going to miss every one. What is the equation of line L? Any vertical line fails the vertical line test. Therefore, it is not a function and cannot begin with y equals, like B, D, and E. This graph hits the x-axis at +1, so the answer is A, x equals 1. Everybody, I had a whole lot of fun today talking about equations of lines, whether they be vertical, horizontal, or having slope, and I can't wait to see you next time.